constellation Cassiopeia, a vain queen in Greek mythology. That constellation kind of looks like a W. And if you take this part of the W, it's just sort of a V, and extend it down, you'll find the Andromeda Galaxy. If you take the other part of the W, this part here, and extend it down, you come to a pair of clusters known as the double cluster in Perseus, a fine sight through binoculars. This is about what it looks like. Two clusters of stars gravitationally bound together. In the constellation Orion, there's a beautiful object to see right smack in the middle of the sword. That's the Orion Nebula, a giant glowing cloud of gas and dust within which new stars have recently been formed and are still forming before our very eyes. Now, when you look through binoculars or a telescope, let me note that you will not see the vivid colors that I've been showing you in these images. That's because your eyes don't work very well at discerning color when they're observing very faint light. The cones in your eyes don't work well when the light is very faint. They only work well when the light is bright. So when you're staring at these faint objects, even through binoculars or a telescope, you're just barely seeing them, and the colors will simply not register on your eyes. These colors are seen in photographs taken through multiple filters and combined together to bring out the true color of the celestial object. Looking now at a wider view of Orion and Sirius and other places along and close to the Milky Way, you come to a group of stars up here called the Pleiades, or the Seven Sisters. These are a fine sight through binoculars. Again, they are a gravitationally bound cluster or grouping of stars. A really fun thing to do with binoculars is to simply cruise around along the Milky Way. I said in the previous lecture that the Milky Way is fun to look at simply with one's naked eye, and that's true. But you see more details, you see more nebulae and clusters if you look through a pair of binoculars. Let's examine a few of the objects that you can see. A rich part of the Milky Way is near the tail of the Scorpion. Look at all these clouds of gas and dust. Here, with the naked eye, you might have been able to see just barely some of these features, but through binoculars, they come out more clearly. You can see these objects as distinct clouds of gas glowing in these regions of the Milky Way. And admittedly, with shaky binoculars, you might not see all these little details, but you will at least see the general shape of the object. Another fun thing to look at through binoculars is the moon. The moon, through binoculars, shows an irregular surface with craters and lava plains, the maria, the seas as they were called initially. We now know that they are not water oceans, they are just frozen, dead lava plains. But Galileo saw that the moon is pockmarked with lots of craters and other things like that. It was not a perfect celestial object, and this caused some concern, as I'll discuss when we talk about Galileo in more detail. The moon is just a great sight through binoculars. Well, with a telescope, you can get an even more detailed view of celestial objects, because telescopes, first of all, are mounted usually on a tripod like this, making them steady, so you're not shaking around as you are with binoculars. And moreover, the mirror or the lens can be made much bigger than in the case of binoculars. So it can collect more light, it can magnify the light more, and it can provide greater clarity. Accomplished amateur astronomers routinely not only look through telescopes, but take wonderful photographs with them. And many of the photographs that I show throughout this course were given to me by amateur astronomers to show in the course, and I'm very grateful to them. I'll acknowledge a few of the specific contributions in this lecture. Stefan Seip took this wonderful view of the moon. Look at those craters. I mean, oh gosh, could you just imagine standing there and taking a hike through this area? It would be fantastic. Notice that the craters are most easily seen near the place where darkness begins on the moon. That is, this is the location where either sunrise or sunset is occurring. And at those locations where sunrise or sunset is occurring, the light is coming in at a glancing angle, so the shadows are long, just as the shadows are long on Earth near sunrise and sunset. And many of the best photographers, of course, take some of their most famous photographs during times of sunrise and sunset, not when the sun is straight overhead and the contrast isn't great. So similarly, when you're looking at the moon then, you should concentrate your attention on the area near sunrise and sunset, the so-called terminator. That's the terminator. Not that it's going to kill anyone or anything. It's the termination of where the light shines on the moon. And here we're just drifting across the moon, and look at all this wonderful detail. You can see ridges here, which are the tops of craters. There's the top of a crater lit up. Here's the top of one lit up. There are mountain chains. There are valleys. There are ridges here. There are craters within craters. Look at that one there. There are relatively clean craters on top of smooth maria. There are other places where craters are on top of craters. Multiple impacts have occurred. The moon can provide almost endless fascination to someone who's looking at it carefully through a telescope. Here's a beautiful sight. These are the high ridges surrounding craters that are still lit up by the sun, even though most of the surrounding area is already in darkness. So these are mountaintops, or the ridges at the tops of craters. So the moon is just a wonderful sight. Sometimes you can see the moon occulting or covering up one of the planets. Here's a wonderful series of photos by Heidi and Isaac Kikuwada showing Saturn being gradually covered or blocked by the moon. That's called an occultation. The Kikuwadas also took this picture of Saturn, showing what Saturn looks like through a modest-sized telescope. You can get a thrilling view of Saturn through even a small telescope. And I remember, as a freshman in high school, receiving a telescope for Christmas, taking it outside, and the third bright object I happened to point at was Saturn. And it just knocked my socks off. I couldn't believe it. I had discovered Saturn at that moment. No one told me to point at that bright star. I was getting kind of bored after looking at one or two stars. They just look like points through a telescope. So I thought, okay, I'll look at one final star, and then I'll pack it up for the night, and I'll go to the library the next day, and I'll look up where all the good stuff is, the galaxies and the planets and all that. Well, the third object I looked at was Saturn, and there it was, and I could see the rings, and I, that night, discovered Saturn. And I experienced the thrill of discovery, even though millions of people had seen Saturn before. That night, I discovered it. Imagine the feeling that a scientist has when he or she figures out something for the first time ever in humanity. It's a really exhilarating feeling. It's a real rush, and this is why we become scientists. Here's a photo of Jupiter through a modest-sized telescope, again by the Kikuwadas. If you watch Jupiter over an extended period, you will notice that it has moons that orbit around it. Not only is Jupiter itself rotating about its axis, as the Earth is, but it has moons orbiting it. And it is these orbiting moons that Galileo so famously saw in his observations around 1609, 1610, and which showed that Earth is not the only object around which other things can orbit. That was the prevailing view at the time, that everything circles the Earth. Well, not so. Some things circle Jupiter, suggesting that Earth might not be the one central object in the universe. Through a small telescope, you can also reproduce another one of Galileo's observations, one that provided an even more fatal blow to the Earth-centered geocentric theory of the universe. And that was the phases of Venus. Venus goes through a complete set of phases, and later I'll explain why that disproves the Earth-centered model of the universe. So you can see that with a small telescope, you can reproduce some of the observations made 4 centuries ago by Galileo as he provided evidence that resulted in the Copernican revolution. Going back now to the Summer Triangle, a familiar place by now from which we can find lots of other interesting objects. If you go to the Northern Cross, or more formally Cygnus the Swan, and go down to the bottom part of the cross, the end star, or the head of the swan if you prefer, and look at it through a telescope, it appears as a double star. Now, with the naked eye, it looks just like one star, but through a telescope, it appears as a double star. This is an example of a binary star system. We'll discuss them more later. But over half of the stars you see in the sky, though apparently single, are actually multiple systems with 2, 3, or 4 stars or more gravitationally bound together and orbiting one another. And I particularly like this pair because the colors are blue and gold, and those happen to be my university school colors. The University of California at Berkeley, or Cal, has colors blue and gold, and a few years ago I got the Academic Senate to informally recognize Alberio Beta Cygni to be the official Cal school star. Near Vega is another constellation called Hercules, and its main part is this structure here, and that little dot there is a cluster of stars, a globular cluster consisting of hundreds of thousands or even 1 million stars gravitationally bound together in a very tight grouping like this. Globular clusters are a wonderful sight, especially through big telescopes, because you can see just a myriad of stars there, all clustered together, much more closely than the stars in the vicinity of the Sun are clustered together. Going back now to Cygnus the Swan, or the Northern Cross, shown here, that was Alberio there. If you go to Lyra the Harp, you can see within it a cloud of gas called the Ring Nebula. It appears right between these two end stars of Lyra the Harp. It's the Ring Nebula, and it's the cloud of gas ejected by a dying star. Our Sun will do something like this in about 6 or 7 billion years. In a cosmic burp of fairly minor proportions, it'll eject its outer atmosphere, and it'll do this multiple times during its slow death. If you go to the Big Dipper and find the end of the handle and go down a little bit like this, you can get a nice view of a beautiful galaxy, the Whirlpool Galaxy. And although you won't see as much detail through a telescope as you do in these photographs, I won't lie, okay, you can see more in the photographs, nevertheless you see enough through a telescope to give you a pretty stunning view. And when you recognize that the galaxies that you're seeing are millions of light years away, and it took that long for the light to travel, it becomes even more awe-inspiring. Going now to Orion, in the sword of Orion is the Orion Nebula, and a view by Richard Crisp shows it very nicely. All these glowing gases illuminated by hot young stars. Those young stars can be seen in the middle of the Orion Nebula. We can tell that they're only a few million years old, which is young by cosmic scales, and I'll tell you later on how we can tell their age. And their radiation is illuminating the surrounding clouds of gas, causing them to glow. And it is within these clouds of gas and dust that new stars are forming even as we speak. Well, if you go out to your local amateur astronomy club, and they hold these star parties, okay, where they bring out their telescopes and their binoculars, and they're eager to show you the splendors of the night sky. They love showing you things. You know, each one says, "I'm proud of my telescope. Look at the view of Jupiter or Saturn," or whatever. These amateur astronomy organizations are a wonderful thing. They provide a fantastic public service because they allow the general public, most of which does not own any telescope, to come out and view objects like this through equipment which in some cases is pretty big and expensive, but they're happy to share the splendors of the night sky with anyone who is interested. I hope that in the past few lectures you have seen that there is a tremendous amount to be seen in the sky with the naked eye, with binoculars, and with the telescope. And just as one should take time to smell the roses, all of you, I hope, will take the time to go out, look at, and appreciate the night sky.